Um, the passion I wanted to talk to you about today is the Rubik's Cube, as this is something that's been part of my teaching since the early 80s. Actually, I've got a very big collection of cubes at home and different puzzles and books. I have about 50 books in the Rubik's Cube that were brought out in that era, and a lot of puzzles. You're looking at some of the puzzles here. There's one you may never have seen before called the Rubik's Cube, but Rubik's Clock. And the clock is amazing. It's a great puzzle. So that's something you may want to look online and order one, because it's just as good as the cube, that particular puzzle. Back when I was teaching at Oakville Trafalgar, I ran some Rubik's Cubes contests for my students. And some of the local papers picked this up and ran some stories in this, but I was actually in the early 80s running contests at my school. And I was teaching students how to solve the cube. That was the main point of it. And I had a number of students that really got into the cube, through this experience, which led to some mathematics. And that's one of the points I want to make today with you, is that it's the mathematics of the cube that is amazing. I spent some time with Professor Rubik, and this is a picture of me with Rubik here, and I'm doing a cigarette trick. I wish I could do this trick for you, but we're not allowed to smoke here. So I'll just tell you the way this trick works. I take someone's coat, form a little well into it, and you take a lit cigarette. This is the way the trick would work. I can't do it for you, but you would push the cigarette into the coat here, and people are wondering, like, what's going on with the cigarette? And then you just go this, and the cigarette has just vanished. So it just goes. It's as I say, I wish I could do the trick for you, but I can't. So, but anyway, it was a beautiful trick. There's a lot of mathematical moments I had with the cube, and this is one of them. If you take a Rubik's Cube in your hand, and if you do a move on it, just make up some move, and if you do it over and over and over again, the cube will come back. So there's some moves right there, like the bottom one. If you do that move over and over again, after 1,260 times, it'll come back. And it's pretty amazing. There's all sorts of things in our curriculum that are like this. I mean, take a look at 1 over 7. When you divide 7 into 1, it repeats, it loops back around. The function that I have listed there, x minus 3 over x plus 1, if you do f of x, you'll come back to x. It loops around. If you take a deck of cards and do a shuffle with the deck of cards over and over and over again, the deck comes back. And there's a beautiful sequence there that if you pick two numbers, a and b, and if you work out b plus 1 over a, and you just do that over and over and over again, the sixth term loops back around to the first term. So these are all the same as the Rubik's Cube, where things loop back around. There's some great mathematics in this. You can teach inverse functions with the cube. This is something that I was doing in the early 80s and throughout my career. I mean, there's the typical way of switching x and y, that you do. I mean, I'm not so sure kids really understand that method, but if you just take a cube in your hand and do a series of moves on it, you can ask your students, how do you get it back? Well, you just start at the last thing you did, and you do the reverse of them, and you work your way back. It's the same with a function. I mean, if you have 5x cubed minus 2, the first thing you're doing is cubing and all of that. It's easy. There's also these worlds. Like, a great question is, how many combinations are there with the cube? And these are the worlds that you're looking at here. If you take a cube and take it apart, and if you take one corner and switch it, and then put it back together, you can't solve the cube. It's in a different world. So it turns out when you work out how many combinations there are for the Rubik's Cube, the way you buy it, you have to divide by 12 because it's in one of the worlds. I also got involved with some commercials for television, for base cell margarine and for Cadbury's. And I was involved with them. I had to set up, this is an amazing commercial, especially the one that Base Cell did. And one of my students from Oakville Trafalgar was involved with this commercial. She was the hand model for this. And it was a very complicated series of turns that happened on television with the cube. But I had to figure out how to turn just the centers of the cube. And that was amazing. One of the things that I was inspired by early on was Doug Henning. Doug Henning took a Rubik's Cube in his hand in an NBC special, and he threw it up into the air, and he caught it. And it was just done. The cube was finished. And I couldn't believe this. Anyway, I was involved with the Rubik's Cubes contests. And so I had to go on television, on global television and elsewhere, to promote the cube. And I wanted to do what Doug Henning did. And I couldn't figure out his trick. So what I came up with was taking a scrambled cube and just putting a cloth over top of it, and then just magically making the cube get restored at the end so that it would come back. So You know, that was my version of Henning's trick. If you want to learn more about the cube, there is a ton of stuff online. You can find all sorts of things. And if by chance you could go to the Phillips Exeter Academy Conference someday, because there's a teacher there named Ian Winokur who actually teaches a week-long course on the cube. And it's just an amazing course that he teaches. So it's something you might want to, take a look at his course. Thanks very much.